Right, so in class we used our example to see if having voted for Trump had an impact on whether or not we were currently approving of the President of the United States. So we talked about a couple of different things. We talked about looking at row percentages. We talked about looking at the pie charts. We also talked about the idea of wanting to see if there was this relationship between them by looking at expected counts versus observed counts. And so this idea is going to show up in the steps that we're doing, more specifically inside this test statistic that we're looking at. So when we ended class, we talked about the idea of wanting to see if there was a relationship, or in a sense to see if our pie charts look very different. So when we looked at our pie charts before, right, these appeared to be pretty different. But the real question is, right, there's sample sizes that make up these numbers. Are they enough different to really think that having voted for Trump has a real impact on if you currently approved of him or not? So the hypothesis test will specifically see is that a strong enough of a relationship to see that yes, there really is a relationship based upon just our sample of data. So if you remember from our one categorical variable part 2 notes where we first introduced hypothesis testing, there are 5 steps to a hypothesis test. The first step is always the hypotheses, or the null and alternative hypotheses. Now here, unlike the previous set of notes where we talked about hypothesis testing, there are actually no numbers that show up here. It's really all words that we're going to have here. And the alternative hypothesis is that the response variable is dependent on the explanatory variable. And we talked about defining these 2 variables in class. Or in a sense, what the alternative hypothesis is trying to say is that there is a relationship between our 2 variables. That the one is impacting the other. Versus the null hypothesis, or what we assume to be true until we know otherwise, is that there is no relationship between our 2 variables. And so what that would mean is that the response variable is independent, which independent just forcibly means not affected by the explanatory variable. So that is going to be exactly the same. Our step 2 is still the same. We're still going to reject the null, and then I'm going to add in the and believe the alternative here if our p-value is less than alpha. So that stays the exact same as it was before. Now we need, for 3, we need our conditions first. We're still in this idea of a relatively random and unbiased sample. There's only a second condition here, that all the expected counts are at least 5. And in class we talked about how to calculate those expected counts. Let me zoom in here a little bit better. So on page 6 we talked about actually how to calculate them. And then we actually did it for our first example. So these expected counts are, if they are independent, what kind of counts I would expect to get. And then I'm able to compare these numbers to what we observed, but we want all of these expected counts kind of inside the table, not in the totals, to be at least 5. This is very similar to our n times p hat being at least 10 type of conditions that we've had before. The other part is our test statistic, which up until this point had been a z that we've talked about. We actually have a new test statistic here, and it's the Greek letter chi, and it's squared. And how we calculate that is we're going to be summing. That's all this capital sigma means, is to sum, or we're going to add some different things up. And what we do is we take our observed minus our expected squared over the expected. So O just means your observed count, or your actual data, and the E is the expected. And so we're going to take basically how to compare our observed versus what we expected. So how different is what we got from what we expected? We're basically squaring it so that the negatives and positives don't really matter to us. But then we scale it by the expected as well. Then we will add up those numbers, and we will do this in our first example together. Right now we're just talking about the idea of the formula. So we'll talk about what we're specifically looking for in this number and how to calculate it together in class. As it says here, we're going to let Statcrunch do this for us primarily, but we will talk about what it's actually measuring and how to calculate it together in class. Then we're going to get our p-value, and that p-value is going to come from Statcrunch. And we'll use that p-value, go back up to our step 2 to make our decision, just as we have before. And then finally, we will interpret it in the context of the problem. Since we're going to let Statcrunch do most of the work, on this next page is the actual Statcrunch Directions, which there are 2 different ways that we'll be doing this, and I will show you how to do both. I'll actually kind of do it here real quick, and then we'll do it together in class as well. So there's 2 different ways. You either need the summary or the actual data. And so I'll bring back up the President of the United States example that we will be doing in class. So this is what it would look like if I had all of the data. For each individual person, I have both variables if they approve, disapprove, or are neutral about the president, as well as if they voted for him or not. So that's what the data would look like. And then following my directions then with the data, we're going to go to Stat, Tables, Contingency with Data. Stat, Tables, Contingency with Data. Then it says we're going to select the row or the explanatory variable and the column or the response variable. So our row variable was if they voted for him or not. The column variable was their opinion. And there's other things that we can click here to get things that we will possibly click are row percents. And then if you control, you can click more than one thing. Expected counts. And this contributions to chi-squared are the 3 main things we'll get here. And then we'll hit compute. And this will give us the output that we need. The other way is just having the summary information. And what having the summary information would look like would basically just be having that contingency table for us. So back on page 3 of the notes, I would have that. So I had if they voted for him or not. And then I had if they approved, disapproved, or were neutral. And then I would just put in those counts that I had there. And notice here when you put in the table this way, you don't put in the totals because Statcrunch can do that math itself. So I do not want to put the totals in. So it would look like that. Now we follow with summary options. So I go to Stat, Tables, Contingency with Summary. And then here, I select the appropriate columns, basically which ones I want to compare, and where I stored my row names. So I want to compare the disapprove, neutral, and approve. Those are my 3 columns I want to compare. My row labels are in this column called vote. And then just as before, I can get the row percentage, control click, expected counts, contributions, just chi-squared, and get my results, which will be exactly what we had here as well. So it just matters if you actually have just the table or if you have the actual data, which way you will go for that. Right, so I'll demonstrate that Statcrunch stuff together in class as well, because it's nice having this video to refer back to, like when you're doing your extended assignment. The code word that we're going to be using today is one of my daughter's favorite stuffed animals, and that is her Yoshi. Alright, so we'll pick up by doing the example of the hypothesis test together in class. And we'll talk about what the chi-squared value is actually calculating, how to calculate it, and what it means.